In this video, we are going to talk about the survival analysis. Okay, when you do the research, if you have, if your data, if your research is focusing on uh, how many days or how many hours or how many years a person or an organism survives after certain treatment or certain event or certain things. If you want to draw the graph of that, this is how the survival analysis is. And if you want to analyze the difference between the two drugs, two therapies, all those kind of things. Okay, so is survival analysis is useful. So first of all, we will go over the life tables. Okay, so the life tables are the tables that is evaluated and and continuously updated by government agencies. Life table consists of information about death rates and longevity, as well as probability of dying during all age intervals and other informations, such as number surviving to the beginning of the year, number of deaths during a year period of for different age groups, expected remaining life, and so on. Okay, so insurance companies use life tables to determine the insurance premium. Many health related analyses and studies involve life tables. So there are different type of life tables. Cohort generation life tables is a record of actual observed mortality experience for a particular group, such as people born in the year of 1985 and so on. That is called the cohort. So you consider a group of people that is born in a certain year or certain group of people, and then you study the life mortality experience of those peoples only. Okay, this kind of data are hard to collect or complete over periods life data, so not much practical and not popular to use. So the period life tables or the current life table describes mortality and longevity data for a hypothetical cohort with the data computed with following assumptions. The conditions affecting mortality in the particular basis year remain unchanged throughout the lives of the everyone in the hypothetical cohort. A period life table shows the long-term mortality conditions that were present during the particular basis year. So these life tables can be found online, including life tables with respect to various subgroups such as gender, race, etc. The following are the components of life tables. So the period life tables has these components. Okay, so these are the components of the life table. One is the age. Age is given in the interval. This is like x. This is the one more than x. X plus 1, right? 0 to 1, 1 to 2, 2 to 3, and so on. That is the age interval is the first column. Second column is the probability of dying. So probability of dying is number of death divided by 10 to the 5, assuming that there were 10 to the 5 newborn. Okay, number of death divided by 10 to the 5 is the probability of dying. Okay, so these divide by that. You see that these are the number of dying between age 0 and 1, right? And then number of surviving people is 100,000 at age 0. That means these are the number of newborns. You see that? And these are the number of people dying in between the age 0 and 1. So what is the probability of dying is these divided by that. Okay, so number surviving is the total minus number dying, right? That is the that will be the number surviving. That is 10 to the 5 minus number dying. So 10 to the 5 minus number dying, that is the number surviving. Number of death is this death is what is the number of death is that number, right? So the number of death is taken out of 10 to the 5 100,000 population. So person year lived is given by the total number of years lived during the age interval by those who were alive at the beginning of the interval. For example, if 100 people were born at the beginning, okay, and if 5 died, so there were 95 people survive, right? So that is the 95 years, because those people spend 95 years in total, right? But so the 5 of them, they died, they might have died at different time of the year, so you add those age of those died people too. So that is basically, so person years lived between age x and x plus 1. So how many years the surviving people lived between the age x and x plus 1. For the first one, it is 0 and 1. Okay, so this is the total number of person year lived above age x. So, and this is the expected life at age x. There are some deaths at the different time of the year. The person year lived is less than 10 to the 5. That makes sense, right? The total person years lived in this and all subsequent intervals. So how many? So this is the total. How many? So for these 100,000 people born at particular year, suppose there are 100,000 people born, right? So how many total number of years they will survive? The total for all 100,000 that survive, because some of them die every year, right? So this is the total number of years they survive, that the people that they were born at a certain time. Okay, and the last one is the expected remaining lifetime is the total person years lived divided by the number of people present at the beginning of the age interval. That means these divided by number of people that lived at the beginning of the year, that one. Okay, so that is, if you divide that by 100,000, you will get 78.7. Similarly, divide that by 99 point, that you will get 78.2, and so on. So this is the expected life. For example, suppose this is a life table for 2015, right? This is given, this is real data. Okay, this is the life table for 2015. So what you can see is, if you were born at 2015, then the your probability of dying between 0 and 1 year is that. So what does this number say? This number says that this is the average life expectancy. Okay, if you were born in 2015, or if you are in age 0 at 2015, then your life expectancy is 78.7 years. You can similarly say that if you are 1 years old at 2015, then you will probably survive 78.2 years, and so on. Okay, so this is how you can interpret for all age groups there. Okay, so let us see an example, a life table where the age intervals have been combined so that the age intervals are longer than 1 year. Suppose you want to find out the average life expectancy, or you can say what is the survival probability of a group of people that has more than 1 year. For example, the survival probability of a person that was age 3, or you can say that a person who was born at 2015 survive the survival probability of a person, or you can say survival probability is 1 minus that thing, right? So the survival probability is 1 minus that number, because this is the probability of dying. Okay, so if you were born in 2015, then the probability that you will die between age 3 and 4 is that. You see that? So if you were born in 2015, then the probability that you will die between the age 12 and 13 is this number. This is how you find out that, right? So but if you want to find out, suppose you were born in 2015, what is the probability that you will die between age 6 and 10? In that case, you will have to add those probabilities, right? Let's look at this example. Find the probability of a person dying between age 13 and 16 years who was born in 2015, right? So solution is number of people at 13th birthday plus number of people surviving at 16th birthday. Oh, sorry, there is minus, right? So number of people at 13th birthday minus number of people surviving at 16th birthday. That is the total death, right? That is the total death between 13 and 16, divided by the number of people surviving at 13th birthday. So we use that table. So number of people surviving at 13th birthday is 99,222, and the number of people surviving at 16th birthday is 99,150. You subtract that and divide by the number of people that will survive in the 13th birthday is that value, right? And you divide by that. This is what you will get. This is the probability that if you were born in 2015, then the probability that you will die between age 13 and 16 years is that one. Okay, so similarly you can find out the survival probability is 1 minus that, right? Okay, so the alternative method is probability of dying between 13 and 14 plus probability of dying between 14 and 15 plus probability of dying between 15 and 16. If you add that, you will get the same number. Okay, let's see another example. Use the life table to find out if there were 339, 3,978,000 births in the United States in 2015, and if the age of receiving full social security payment is 67 years, how many of those born in 2015 are expected to receive the social security payment? So let's see that. Solution is, from the life table, we see that out of 10 to the 5 birth in 2015, about 81,872 people survived till their 67th birthday. That's from that table, right? And thus probability of surviving till 67th birthday is that many survive divided by the total, right? That is 81.81872. Now, but there were these many people born, so you multiply this with the total. That probability with that total will give you 3,256,869 will get the social security. This is how you find out that the number of people who will survive till that age or gets that social security. So next thing we want to do is the hypothesis testing for the cluster or the date. Usually we use 1 or 2 proportion z-test, okay? In a region where 5,000 population reach their 16th birthday, if 25 of them died before their 17th birthday, test if this is significantly higher than the national average with alpha equals 0.05. Solution is, from the life table of the age group, the probability that a person dying between 16 and 17 years is 0.000388. 16 and 17, you see that? This is the probability of dying in that age group, okay? So thus the population proportion of death in that age group is P equals to, that is the proportion value, population proportion. But what is the sample proportion? We got that 25 out of 5,000 died, right? It is the sample proportion. So we want to see if is this sample proportion in that region is higher than the national average. So P equals to that versus P is greater than that. Now we use the one sample proportion z-test, implies that the test value is, so this is the one sample proportion z-test. You see that we saw that in the lecture slide 1, okay? So we found that the P value is 7.26 times 10 to the negative 62, which is almost 0, which is less than alpha. So we reject the null hypothesis. This implies that the sample proportion in that region is significantly higher than the national average, okay? So the next thing we do is the survival analysis. The method we are using here is Kaplan-Meier survival analysis. So let us talk about some of the terminology we use in the survival analysis, okay? So in survival analysis, one of the important term we use is the survival time. In survival analysis, the time lapse from the beginning of the observation to the time of terminating of an event is the survival time, okay? The terminating event can be death or divorce or failure of computer hardware, or because sometimes if you are doing an experiment giving some drug and then see how long they survive or how long it takes to get recovered, those kind of things. So the survival time is the time from the beginning of the start of the treatment to the end of the treatment. End of the treatment can be death or recover, or sometimes people live in the middle, okay? So that's the survival time. So the survivor is a subject that successfully lasted throughout the particular time period. The Kaplan-Meier method is used to describe survival behavior for some specific event, and it is based on varying survival time intervals for terminating event using being analyzed. For example, study of survival times of patients after they undergo some treatment like surgery or some drug, okay? So survival times are sensor data. So what do you mean by sensor data? This is important thing in the survival analysis. If the subject survived past the end of the study, okay, or if the if the person dropped from the study for some reasons not related to the terminating event like being studied, okay? So sensor data is sometimes the person survives till the end of the study, that is the sensor data. Also sometimes the person leaves the study in the middle, and that is also the sensor data. Usually in the survival analysis data, sensor data are marked differently. Sometimes we mark with star, sometimes we mark with plus, and so on. We draw Kaplan-Meier survival curve for the survival analysis. Let us see an example. Consider an example of survival data in months for a group of 12 patients diagnosed with a brain tumor who were followed up to 12 months. So they study for 1 year period, okay? And then what they did is there were 12 patients diagnosed with the brain tumor, and they are studying the survival of those 12 patients. So patient number 1, month of entry, they started to study on from month 0. Time to death is 12. So he survived actually the 12 month, right? S star means it is the censored data, okay? Survived, but star means it was survived till the end, okay? So it did not die till the end, and then it did not drop the study also, okay? So survival time, the total survival time is 12, and so on. So note that on the outcome, the letter D means death. You see that? D means death. So this person 3 month of entry was from the beginning. He died, and after 11, he survived till the 11. So he died after 11 months, or on the 11 months. So outcome is D. Survival time is 11 months, okay? S he survived, and P is the left the study. You see that? P left the study. See? This one left the study. This one left the study. Okay? That's a P star. So these are censored, okay? This is P star. But S star is survived, but it survived to the whole throughout the study period, right? And P star is dropped in the middle. So it did not die during the study. So we denote that by star as well. D is the death, okay? So from the above data, we see that 7 patients died. You see that? 1, 2, 3, 4, 5, 6, 7 patients died. 3 survived before they left study. 1, 2, and then 3 or 2. It looks like 2, right? So 3 survived before they left study or till the study period. Okay, 3. That is till the study. So S star, S star, and S star. And then 2 left prematurely. So 3 of them survived before they left the study or till the study period, and 2 left prematurely. That's how we denote P star, okay? Our goal is to construct the Kaplan-Meier survival table and its curve. So what are the columns that we will need to draw the survival curve, okay? Number 1, the column for time. Number 2 is a column for number of people alive at the beginning of time t. Number 3, third column is a column for number of premature withdrawals during the time t. Okay. Number 4, a column for number of deaths during the time t. Number 5 is a column for number of at risk. How to find out number at risk? We denote by R. It is N minus W plus D. N is number of people at the beginning of time. W is number of withdrawals, and D is number of deaths. So total minus withdrawal minus death is the number at risk. Okay. And a column for D over R. We will find out that too. So which is the probability that a patient will be alive at the beginning of the time t, will die during the time t. Okay. And a column for P equals to 1 minus D over R. We find out all these columns. The probability of surviving to the end of the time period, and a column for a Kaplan-Meier cumulative survival probability. We add those survival probability, which is the cumulative product of all previous we don't add, we multiply all previous probabilities. Okay, let us see that example. So first column is the month t, the first month, second month, third month, fourth month, fifth month, sixth month, seventh month, and so on. Okay, because this study for 12 months, it goes up to 12. Now how many people will surviving at month 1? That's what we want to find out. That's the number still in study, 12. So how do I find out this N is? This is found from the time to death column of previous table. How many people survive? You see that? How many people were still in the study on month 1? There were 12 people, okay? On the month 1, there were 12. For example, there were 3 patients alive till 12 month. 1 patient died or left during 11th month. And 0 patient died, left in 10 month, and 2 patients died, left in 9 month, and so on. Okay? And so on. So you see that on the month 1, there are 12 patients still in study. Withdrawal was 0 on the month 1. Death was 0 on the month 1. Risk. What is the R? R is N minus W minus D, right? That is 12. D over R. So you do D over R is 0. And then P. How do I find out the P? The way to find out P is 1 minus D over R. That will be 1, and S is found by just, it is, so a column for Kaplan-Meier cumulative survival probability, which is the cumulative product of the previous probabilities. So we don't have, so this is just 1. Okay. Now for month 2, how many were surviving for month 2? So there were 12. Okay. And then withdrawal was 0. So similarly, you find out all those. Let us look at this one. So on month 5, okay, on month 5, how many were survived for month 5? Let us go here. So they survived 12 months, 11 months, 8 months, 6 months. You see that? One person died in the patient 7. The patient 7 died on month 4, right? It is D. And patient 8 died in month 5. Okay? So you see that since one patient died in between month 4 and 5. Okay, oh, there he is. There you go. So on month 4, one person died here, right? So number is still steady. On month 4, there were 12 people still on the study, but one died. You see that? And then the at risk were 11 because there are just 11 people left, right? And then you find out D over R, and then P, and then you, to find out S, you multiply all those previous, okay, to get that one. And now what you do is, to find out this one, you multiply all those previous. To find out this one, you multiply all those here, okay? To find out this one, you multiply all those here, okay? So P is 1 minus D over R. That's what you get. And then this one is, you multiply all those. All right. On number 5, there were only 11 people in the study because one died in the month 4, right? And then withdrawal was 0 on number 5, and death was 1. So there are only at 10 at risk. You see that? And D over R, you find out that 1 minus D over R, and then you multiply all those. You see all these. This is how you find out the survival probability. This is important thing. This will be plotted in the graph, okay? To plot Km curve, we plot T versus S. We plot T versus the S. Okay? So the last slide is the Logrank test. We'll do all these things in R, okay? No worries. So if you want to compare overall survival experience of 2 or more than 2 groups, then we use Logrank test. Logrank test actually compares the survival of more than 2. 2 or more than 2. It is a non-parametric test which assesses if any difference exists between the 2 groups of patients in survival time at any point during the study period. H0 is there is no difference in the survival experience. H1 is there is difference. Logrank test uses comparison between observed and expected events, given that the null hypothesis is true. We use chi-square method for the comparison. So we will do all these things in the R. Alright, to do the survival analysis in R, we need a package called survival, okay? We need to install a package and you call the library. So let us consider a data set, that is the built-in data set here. So what is AML data? AML data, the acute myelogenous leukemia survival data. So survival in patients with acute myelogenous leukemia. The question at the time was whether the standard course of chemotherapy should be extended, okay? So look at here. So here you see that, so the time is, I think the time is in month, right? This time is survival or censoring time. So this is the survival time or the censoring time, means the person survived or dropped in the middle, right? Survived till the end or dropped in the middle, or all the survival time too. So this is all those. So status is censoring status. So censoring means 9 is this person either dropped in the middle after 9 months, right? Or this person, I'm not sure whether that is a month or years. It looks like it is month because this is leukemia data, right? So I would not say 161 years. So this is, let's suppose that this is month, okay? So time is in month. So the status is it censored data? Yes, it is censored. Either it survived toward the end or it dropped in the middle. It looks like it dropped, okay? Next is 13, right? The second is 13 months. survival or censored. It is censored, yes. So this was not censored, so it looks like it is dead. Okay, so this is censored, not censored, and so on. So these are the data. And maintained means the chemotherapy was maintained and chemotherapy was not maintained. Maintenance of the chemotherapy. So these are the not maintained. These are the maintained chemotherapy data. Okay, so how do I do this? Is to find out, actually to find out the to draw the survival analysis curve. What we do here is I name like leukemia dot survival. This is just a name, equals to, I do surfit, and surv is the function you will need, time comma status equals to 1. Although I write status equals to 1, you will plot both status equals to 1 and 0. Okay, no worries about that. Versus x, meaning you will see a two survival curve for maintained and not maintained. That is versus x there. So x has two categories there. So you will be plotting the survival curve for both maintained and not maintained. Okay, so data is AML. Let us look at that. Let us plot that. So this will be basically, the plot will be the plot later, but this will basically summarize the data. Okay, look at this. N is 11 for maintained, x is maintained, N is 11, x is not maintained, is N is 12. So events is 7 and 11. So what do you mean by events? So you see that. So how many were censored? 1, 2, 3, 4, 5, 6, 7. You see that? For the maintained group, there were 7 that is censored. And then 1, 2, 3, 4 were not censored, right? That's why that event is counting for x equals to 1. If you do 0 here, then event will show you 3, right? Let us try 0 here and then see. You see that? The event is 4 because there are 4 of them zeros there. You see that? 0, 1, 2, 3, 4. So it depends on which one you want to see. That's what the 1 and the status says. Okay. So I was saying that status is 1 and then versus x. So it will create a table for maintained and not maintained. There is n, that is the events, right? So these are the median of the time. And these are the confidence intervals. So don't worry about all these things, but just look at first column and second column with the first row and second row. Okay. Now let us plot. How does that look like? This is what it looks like. Okay. So let us complete that plot. It has a legend and the title. So what does it say? It says that if the chemotherapy is maintained, then the survival time in months to 50 is, survival probability is 20% chance that you survive up to 50 months, and then 20% chance that you survive 100 months, 20% chance that you survive 150 months if you maintain the chemotherapy. If the chemotherapy is not maintained, then the survival probability is 0 in about 45 months. Okay, you see that the decrease of the probability of survival is very rapid for not maintained one. Okay. So if you look at the summary of that, you see that summary of both maintained and the not maintained. You see that the time and the number at risk, that we remember that we had D over R, right? And number of event, and then survival probability. This is the survival probability. We have that plotted here. For maintained one, the survival probability is 0.9. That is 0.9, right? And then 0.81. Oh, so this is 0.9. This is 0.9. At the beginning, it was 1, right? This is 0.9. The other one is 0.8. Other one is 0.7, and so on. See, you see that the about 20% survive past 50 months, right? For the not maintained one, you see that these are the time, number at risk. So the event is that number of event. Okay, so number of event, maybe this is survived, right, or dead. Dead or let us not talk about this because we did not talk about the number of event. So we talk about time, number of risk, and the survival. That's the only thing that we focus. Okay, so time, number at risk, and then survival probability. That's the only 3 things that we focus. Okay, so this is how we draw the survival Kaplan-Meier curves for certain data. Okay, so let us do one more example. This is the survival library, the long data. Okay, So the lung cancer data is so survival in patients with advanced lung cancer from the North Central Center Cancer Treatment Group. Performance scores rate how well the patients can perform usual daily activities. Okay, so let us see. These are the lung cancer data. Okay, we have what is that? Is institution code. Time is the survival time in days. These are the survival time. Okay, status is censoring status, censored or dead, either censored or dead. Okay, and then censored means either the patient dropped the study or the patient survived till the end. Okay, so censored or dead. So age is age in years. Sex is male or female. Okay, one is male and two is female. So pH echocardiogram is this is performance score. Okay, sorry, echocardiogram performance score. 0 is good, 5 is dead. Similar pH Carnot is a certain way of measuring by the physician. Okay, and there are so many others. Okay, so what we are going to do here is we want to do the SOR fit and SOR. These are the standard and time versus time and the status equals to 2. What is the status? Status is the censoring or dead, right? So this is the 2 is for dead and 1 is for censoring. Okay, and then we are picking 2, so we are doing for dead. Okay, the table will give you the dead. We will see that what that means. And we want to do with sex, so male versus female. So we want to draw 2 curves for male and female. Data is the long and the confidence type confidence dot type equals to none. Let us run that. You see that table here? You see that? So n is 138 for sex 1, for male 138, for female 90. Events is 112 and 53. Okay, so let us, you see that there were events on previous one as well. Events is, so events is that status is 2, that is 2 is the set 2 is dead, right? There were 112 dead, male dead, and then for female there are 53 dead. Okay, now let us plot that data set. You see that, and then let us see the let us plot the overall thing. So this is red is for male and blue is for female. You see that for the days. So we are just checking the survival analysis for male versus female. You see that male has lower survival probability for all the days, only about like for this particular disease, for the cancer survival. Okay, for this particular time, the male and female have the equal probability of surviving about like 770 days. They are almost equal. Other than that, all the other time, if they have the lung cancer, the survival probability of the male is lower than the survival probability of the female. Okay, so if you want to do for pH ECOG, okay, so this is one type of measurement. Okay, if you want to do for that, what was the pH ECOG? Let us see that. pH ECOG had ECOG is 1 and 0. They are giving the number. They are giving the number. Actually, if you look at this, it will tell you what is pH ECOG means. Okay, so pH ECOG is echocardiogram performance score 0 and 5. So we want to see what is the survival probability for different ECOG performance score. Okay, that's the next thing we wanted to do here. That's why I put versus pH ECOG. Okay, and then data is the long. Okay, so let us look at this. If you look at that, let me run all those. So what does it say is, if the performance score is bad, if the performance score is very bad and dead, then it is 0. There is no curve for that. If the performance score is bad, then you will see that the person will die within about 160 days. It will survive and then it will die out. Okay. If the performance score is normal, good, and very good, you see the survival probability. For good and very good, the survival probability is about more than 15%, right, till 1,000 days. With normal performance score, you see that this is that normal one, right? The survival probability is lower all the time, and then almost all of the people will die within 800, let's say 25 days. Okay, so you can see all this. So there is one more example I have done here, so you can run this by yourself. Okay, so this is how we draw survival plot, Kaplan-Meier survival plot, plot by hand and as well as by R. Okay, guys, thank you.